Have you ever looked up at the night sky and wondered what's really out there? The vastness of space can be overwhelming, but it's also incredibly fascinating. Our solar system isn't just floating in empty space, it's inside a giant, invisible bubble, and that bubble has a tunnel. This bubble, known as the local bubble, is a region of hot, sparse gas. We see a vast, dark expanse punctuated by tiny distant lights. These lights are stars, each potentially hosting its own planetary system. Astronomers have discovered that we live in a vast cavity in interstellar space, possibly connected to other regions of the galaxy by a mysterious magnetic tunnel. This tunnel could be a pathway to other parts of the Milky Way. This changes how we see our place in the universe. We are not isolated, we are part of a larger, interconnected structure. For years we thought the space between stars was just a thin, uniform mix of gas and dust, but it's much more complex than that. Now we know the galaxy is structured, full of bubbles, shells and filaments like cosmic foam. These structures are shaped by powerful forces. Our home, the local bubble, is one of these features. It's a region carved out by ancient stellar explosions, and the discovery of a tunnel-like structure leading out of it raises big questions. Where does it go? What made it? Could it be a remnant of past cosmic events? How does it shape the galaxy? These are questions that drive our curiosity and scientific exploration. The answer starts with a series of supernova explosions that carved out this cavity millions of years ago. These explosions were powerful enough to shape the interstellar medium. Today we're not just mapping the bubble, but also the intricate structures on its surface, including this tunnel. Advanced telescopes and instruments help us visualize these hidden features. So let's explore our cosmic cavern, the tools that reveal the invisible, and the tunnel that might connect us to the wider galaxy. This journey of discovery is just beginning. This isn't just about gas and dust, it's about our origins. Understanding these structures helps us learn about the history of our galaxy. The universe is active, connected, and structured. It's a dynamic place where new stars are born and old ones die, and we're right in the middle of it. Our journey through the cosmos is just beginning, and there's so much more to discover. What is the local bubble? It's a question that takes us on a journey through our own cosmic neighborhood. Picture a giant, lumpy cavity in the Milky Way's Orion arm, stretching about 1,000 light-years across, a vast, almost unimaginable expanse carved out in the galaxy. Our solar system sits near its center, drifting through hot, thin plasma at 1,000,000 degrees Celsius, surrounded by a faint, glowing haze that's nearly invisible to the naked eye. This bubble isn't delicate. It's a region cleared out by a series of powerful supernova explosions over the last 14 to 20 million years, each one reshaping the space around us. Each explosion sent shockwaves that swept up gas and dust, forming a dense shell, the bubble's wall. This shell marks the boundary between the bubble and the rest of the galaxy. The bubble's shape is irregular, stretched and sculpted by magnetic fields and gravity, making it look more like a cosmic cavern than a perfect sphere. On its surface, where gas and dust have piled up, new stars are born, like those in Taurus and Ophiuchus. These regions glow with the light of stellar nurseries. The death of old stars created the conditions for new ones, showing how destruction and creation are linked in the universe. For millions of years, our solar system has traveled through this relatively calm region, shielded from the galaxy's harsher environments, like a safe harbor in a cosmic storm. Being inside may have protected us, possibly influencing the rise of life on Earth by shielding our planet from dangerous cosmic rays and interstellar threats. We are, quite literally, bubble dwellers, living within the walls of this ancient, invisible structure, shaped by the universe's most dramatic events. And only recently did we discover our cosmic house and its mysterious corridor. Where does it lead? The story of the local bubble is just beginning to unfold. How do you see a bubble made of nearly invisible million-degree gas? Not with regular telescopes. Astronomers use X-ray telescopes like ROSAT, which first revealed the local bubble's faint glow in the 1990s, but ROSAT's view was blurry. Newer missions, XMM Newton, Chandra and Gaia, have given us sharper 3D maps. By combining X-ray data with star positions and interstellar gas maps, scientists can model our galactic neighborhood in detail. This fusion of data revealed not just the bubble but also the intricate structures on its surface. Now we can see where the shell is thick or thin, where stars are forming, and most excitingly, where there are openings or tunnels. Modern astronomy is a team effort, many instruments, one big picture, and that's how we found the tunnel. Here's the thrilling part, the tunnel. As astronomers mapped the local bubble, they found an elongated, tunnel-like structure pointing toward Centaurus and Lupus. This tunnel connects our bubble to the Centaurus-Lupus supershell, a cosmic hallway to the next cavern. It's made of magnetic fields and neutral hydrogen gas, stretching for hundreds of light-years. By combining X-ray and radio data, this filament popped out, linking two massive bubbles. The discovery suggests bubbles across the galaxy might be interconnected, forming a vast network. Gas, magnetic fields, and cosmic rays could travel these highways, shaping the galaxy far beyond their origins. This tunnel is a laboratory for understanding how the galaxy recycles material and energy. It's a brand new piece of the puzzle of our galaxy's evolution. The idea of cosmic tunnels isn't new. It's a concept that's been circulating among astronomers since the 1970s, sparking curiosity and debate for decades. Back then, astronomers like Carl Hiles and Elihu Bolt proposed that our galaxy was far from uniform. Instead, they imagined it filled with vast, interconnected bubbles and tunnels, shaped by the explosive force of overlapping supernova remnants. They speculated that our solar system might actually reside inside one of these mysterious tunnels, but the technology of their era simply couldn't provide the evidence they needed. Their theory was bold and ahead of its time, challenging the prevailing view of a smooth, featureless galaxy, and opening the door to new ways of thinking about our cosmic neighborhood. In the 1990s, the Rosat X-ray telescope provided a breakthrough. Its data confirmed the existence of the local bubble, and new models showed how these bubbles could merge, forming the tunnels Hylas and Bolt had imagined. Yet for years it all remained theory, an intriguing idea waiting for the right moment and the right tools to be proven. That moment finally arrived with the combination of Gaia's ultra-precise star maps, detailed dust maps, and comprehensive radio surveys, which together revealed the intricate structure those early astronomers had predicted. It's a perfect example of how science works: bold ideas, decades of refinement, and at last, the evidence that turned speculation into fact. The past wasn't wrong, it was simply waiting for the right technology and the right questions to unlock its secrets. Now, for the first time, we're seeing the galaxy as a connected, dynamic ecosystem, full of structure and movement. And the tunnel is real, an extraordinary bridge between old theories and new discoveries. These tunnels could change how we understand star and planet formation. Starbirth needs cold, dense gas, raw material gathered in the right place at the right time. The local bubble's shell triggers star formation by compressing gas, but tunnels add a new twist. If tunnels act as conduits, they could transport gas and magnetic energy across vast distances, delivering fresh material to star-forming regions. This could explain isolated star nurseries and help distribute heavy elements like carbon and iron, essential for planets and life. Magnetic fields in these tunnels guide gas clouds, shaping how stars and planets form. The tunnels aren't just highways for matter, they're rivers of magnetism, organizing the galaxy's construction projects. Mapping this network helps us understand the origins of stars like our Sun and planets like Earth. The story of the tunnels is the story of cosmic creation. The discovery of a tunnel in our local bubble is just the beginning. The challenge now is to prove these tunnels are common, not just a cosmic coincidence. Astronomers need to find more tunnels, mapping connections between other superbubbles. This will require even more sensitive telescopes and creative data analysis. Future instruments like the Square Kilometer Array will help map interstellar magnetic fields and hydrogen gas in unprecedented detail. Despite the challenges, excitement is high. This opens a new field, the connectomy of the galaxy. We're moving from rough sketches to detailed 3D maps of our cosmic home. For millions of years, our solar system has traveled through this bubble, shaped by ancient stellar explosions. These discoveries remind us, we're not separate from the cosmos, we're part of its story. Unveiling the local bubble and its tunnel is another step in understanding our connection to the stars.